take this over. So this is the Chuck-a-Luck payout scheme.
It's like chocolate.
Chuck-a-Luck?
Chocolate.
Sure, whatever you want. Nobody plays it in America. It's more of a British game for some reason. So I'm gonna make one extraneous little column off to the left, which is the number of fives, just to keep track. 0, 1, 2, or 3. Okay, because that's what we have to roll in order to win a certain amounts. The actual data I'm interested in is how much money I win or lose. So I don't really want to average the number of fives. I don't care about the number of fives I get. I care about how much money I get for those fives. Does that make sense?
Yeah.
So the actual amounts, these are my winnings. That's what I care about. I care about this. So my winnings, I lose $1 if I don't get any fives. I win $1, which means I profit 0 if I, 1-to-1 payout, I guess, if I roll exactly 1 5. I win $2, profit 1, and then I win $10, profit 9. So the payouts are 0-to-1, 1-to-1, 2-to-1, 10-to-1. And those are the residual profits that you get, the winnings you take back. Winnings is, I guess, a loose term, because sometimes they're losings. Or we'll call them negative winnings. That makes it easier. It makes it mathematically correct, too. Cool? Now, one way you could answer this, I would argue it's incorrect, is if I asked you what your average winnings are, you could go -1 plus 0 plus 1 plus 9 divided by 4. You could do that mathematically. You'd also be wrong. Why?
Because it would come out positive.
Well, because you'd have positive winnings on average, which doesn't make any sense,
It
right?
doesn't show the ratio.
Alicia, hold that thought. Hold on, Scott. I love it, Scott. I love it, Scott. Hold that thought. Hold on. Go, Alicia.
Doesn't show the it's not representative of the probability that you would hit each of them.
What assumption are you making if you just add them up divided by
That
4?
it's all equal. You
That
could
they're
hit
equally likely, that essentially it's a 4-sided die, and you're rolling it, and each side comes up with the same frequency. But we're seeing right now that doesn't happen. Look how stable they are now.
and look
Totally
at how
stabilized,
low-
right? Go ahead, Alicia. Go ahead. What's on your mind?
Well, and just how much further the
Uh-huh.
3 5s has dropped.
Yes, exactly. Now we're up to 28 3 5s out of 7,200, 29 out of 7,200, 0.004. Not that far off what it should be. Right, not that far off what it should be, but definitely depressing when you view it. This is why I get so pissed off with that billboard on Business 97. Somebody just won $948,000. Could you be next? What do you think? Could you be next? I mean, seriously, put that graph next to it. I almost want to. You think I get yelled at if I spray painted on top of that, this graph? Not if I did it well.
Don't get caught.
Just don't get caught. That's a good answer. Don't
I
get
was
caught.
just counseling for
Oh
gambling
my
addiction.
God! It's like I just want to put that graph next to it and be like, this is what you're talking about.
Yeah.
This is what most people are going to do. Anyway, Taryn, back to your question in a second. With me so far? Now, what I'd like to do is stop it right there. Let's use those as our probabilities for argument's sake. Granted, they're going to fluctuate a little bit as time goes on, right? But let's use those probabilities to argue with. We can always let it run 100 more trials and do it again. It won't make that much of a difference. They've already stabilized at almost 10,000 rolls, 8,200 rolls, 8,300 rolls. Let's problem in. The probability that you're going to lose your ante is therefore about 57.73%. So Taryn, back to your awesome question. That's a big number, yes? It's the biggest number. But you got to remember, in the other 43% of the time, you're going to win something back. You see how they get you? They get you, right. They get you because this is the largest probability, right? But that's only 58% of the time. The other 42% of the time, they're handing you money back in different amounts. But you're psychometrically getting something handed back, which plays with that part of your brain that says reward, reward, reward. Right?
Even if it is your own reward.
Even if it is your own money you're getting back, right? And see, watch this. Look at the next one, 35-13. That means 1 out of 3 games you play, you're getting $1 handed back to you. That's frequent reward, is it not? That's frequent reward. That keeps you playing. It's Pavlov, right? Ring, salivate, right? That's what it is. And then interspersed in there are the big payouts, right? You've got a 6.77% of not just getting your ante back, but also getting back $1. And then every once in a blue moon, roughly defined mathematically as 0.0037, you get the big win, the outlier win, right? So you could argue, statistically speaking, That's the only real true outlier of the data set. In one way of measuring outliers, right? These are all above 5% occurrence. That means they occur fairly frequently. This occurs 3 times out of 1,000 or 4 times out of 1,000. That is far, far too infrequent to call it anything but an outlier. So I put it on the billboard again? Why put it on the billboard again? Oh, don't worry about poker. Poker's a game of skill. I can't analyze
Video
that.
poker.
It's still a game of skill, though.
Yeah.
You have to know when to stop. I was going to sing to you, I'm not going to now. But yeah, you have to know when. You got to know when to stop playing, when to start playing poker, right? Go ahead, Linda, you can do it for us. That's awesome. You can do it. That's why I'm looking at Chuckle Up, Craps in 105, the Roulette Wheel in 105. Pure chance, right? Pure chance, nothing but chance. Is that fair?
Yeah.
Okay. What I'd like to do now is calculate the average winnings based on this. Are we solid with this? Do we believe these numbers? I'm tempted to stick with believing them. Let's manually calculate the average. I don't want to use one bar stats just now. I want to make sure you remember what one bar stats is doing for this. I don't care about standard deviation right now. I don't care about that right now. I care about the average because I want to imagine what happens over time if we had an infinite supply of $1 bills and we kept playing this game. Is this believable? Let's go to this board over here and do it. Turn the screen off now. We don't need it anymore. And I want to go back to the idea of a weighted average. And we haven't done one of these since Bert and Ernie. Actually, since your GPA, which I think was around Bert and Ernie.